If the laws of our universe were ever so slightly different, human beings couldn't exist. Are we so incredibly fortunate? I'm never comfortable leaning on luck. How could such exquisite fine-tuning be? All explanations have problems. No explanation? That seems bizarre. In my journey to understand what, if anything, existence is all about, there is no question more central. Is our universe fine-tuned for life and mind? I'm Robert Lawrence Kuhn, and this is Closer to Truth. Martin Rees, the UK Astronomer Royal, is exceedingly knowledgeable about the universe. What is it about the apparent special nature of our world that intrigues Martin? We meet at Trinity College, Cambridge, in his on-campus home. Why does he take fine-tuning so seriously?
Well, first of all, it's remarkable that the complexity of our world can be explained in terms of simple physical laws, and that these laws, which we can study here in the lab, apply in the remotest galaxies. Were that not the case, we make no progress at all in the subject. But we can also isolate a few key numbers in physics whose value is crucial for the way the world is. The first is a number I call n, which reflects the weakness of gravity compared to the other forces important in atoms and molecules. It's a number 10 to the power 40, 1 followed by 40 zeros. This is the ratio of the electrical force between two protons or two electrons and the gravitational force between them. And it's because that number is so large that the only objects where gravity is important are hugely big compared to atoms. You have to have something as big as a star or a planet before gravity can catch up with all the other forces. Were that number not so big, it would not be possible to have objects like us, who are extremely large compared to the microworld and contain layer upon layer of complex structure, but still small enough that gravity doesn't crush us. If that number was smaller, then the universe would be smaller, stars would be smaller and shorter lived, and there'd be no time for complexity to build up. So that's the first number. And there's a second number which is important for the existence of all the atoms we're made of. We're not made of just hydrogen, we're made of carbon, oxygen, and all the others. And for a complex atomic nucleus to exist, there has to be a balance between two forces. There's the electric force, which tends to disrupt all the protons the nucleus is made up of, but there's another force called the strong nuclear force, which binds the nucleus together. And were it not the case that there was a balance between those two, we would not have both hydrogen and helium and all the rest of the periodic table. And it's crucial that that exists because we're made of these atoms, and also it's the nuclear fusion of complex nuclei from simple ones which keep stars shining. All the atoms we are made of were synthesized in stars which died before our solar system was born. We are the ashes of long-dead stars. If you're less romantic, we're the nuclear waste from the fuel that kept those stars shining. So that number, which reflects a balance between these two fundamental forces in the microworld, has to be tuned within a fairly narrow range.
So when you reflect on all the fine-tuning necessary for us to be sitting here, what does it make you feel like?
Our universe started off with this hot amorphous Big Bang, so-called, and evolved first galaxies and stars, then planets around some of those stars, and then biospheres around some of those planets, and then on at least one biosphere around at least one star. Creatures evolved to a level of complexity that in their brains there was something that could wonder about the origin. And that's an amazing thing, but that would not have happened had it not been for the numbers in this particular range.
Martin has 6 numbers which describe the deep structure of the universe. Were any of them even slightly different, stars and planets wouldn't exist. Forget about us. There must be an explanation. But must there? I'm cautious with obvious answers. Chance, necessity, creator, all have hidden traps. I'd like a scientist who knows, or thinks he knows. Leonard Suskin says he can explain fine-tuning. That's quite a claim, but when Lenny talks physics, he's a founder of string theory, I listen. I visit him at Stanford. Leonard, everyone today is talking about fine-tuning. Why?
Well, it seems that the laws of how the universe evolved seem to be special in the way that is just very, very conducive to our own existence. The laws of physics could have been very different. What would happen if you threw away the electron?
No chemistry.
No atoms, no chemistry, no biology, no people to ask the question. You could change the rules in other ways. You could make gravity stronger. Gravity is very, very weak. If it were just even a little bit stronger, stars would burn out too quickly. They wouldn't live long enough for life to evolve. Instead of stars, instead of galaxies, we'd have black holes. And so everything seems to be almost on a knife edge.
All right, let's talk about one of them, though, that has some particular strangeness to it, the so-called cosmological constant.
That's the one which is really on a knife edge. Okay? It is on such a narrow knife edge that it's almost inconceivable. If you were to change it just the tiniest bit, we couldn't be here. This cosmological constant is a kind of anti-gravity. The actual magnitude of it is so small that it is 0.00000. We can sit here for a while. 123 of them.
And then a 1.
And then a 1. I think it's actually a 2. But it is incredibly small, and nobody really knows why. The one thing that we do know is that if it were stronger, it would have blasted apart the galaxies. It would have prevented stars from forming. So you have to understand, galaxies and stars and planets formed because gravity pulled them together in the very early universe. This counteracting anti-gravity could have prevented that.
Okay, we have fine-tuning. We've got to deal with it. Now, there are a number of ways that we can explain that.
Basically, there are 3 explanations.
Okay, number 1.
Okay, God.
Number 2. That one I understand.
Right. Accident.
Okay, that strains credulity just by on its face value.
Right.
So it's an accident just that way, and it happens to work out perfectly.
Right. 123 decimal places, 0, not likely to be an accident. Well, there's a 4th way.
Oh, 3rd.
Let me put the 4th way in before I get to the 3rd.
Yeah.
The 4th way is, who knows, maybe someday somebody will figure it out. But that would partly fall into the category of accident. You take some fundamental equation and you solve it. It would take an incredible accident for it to have a solution which was all that small. The other way goes as follows. The universe is enormously big. We have no idea how big it is. We also have reason to believe that it's diverse, that in different places it has different properties. The picture is that there's some very small fraction of the universe where the conditions just happen to be right for the existence of life. And it's not a surprise, that's where life is. It's more or less like asking, why do we, by accident, happen to live on a planet which happens to be at just the right temperature for liquid water to exist? That's a narrow range. Why is that? Well, the answer is very simple. On planets where there can't be water, there can't be life. Where do we live? We live in the only place we can live, where water exists. Same kind of picture. Universe very big, very diverse, many different environments, a huge slew of different possibilities. And among these possibilities, in a few small pockets of the universe, conditions are right for life, and that's where life exists. Those patches are sometimes called pocket universes. They're sometimes called bubble universes. Some people call it a multiverse.
You like megaverse?
I like megaverse. But we live in one of them. That's the picture.
Lenny needs two assumptions, neither of which is God. First, a vast number of possible universes. And second, a way of populating those possible universes, for which he uses string theory. The result, he asserts, are innumerable universes of all different kinds, at least one of which, our own, can support life. I like the logic. But Lenny, those two assumptions, they're massive. Maybe you're right, but I should try a different perspective. Alex Vilenkin, a Russian cosmologist at Tufts, explores how the universe began. Does thinking about mysterious origins give insight into thinking about mysterious fine-tuning? Alex, you have a nice image in your book. I'm reminded of this nice old man in a beard and having 30 knobs, and he's kind of playing with each one and doing it just to get it right.
That's right. This is one possibility. There is quite a different image of the Creator which can lead to the same observable result. And this is the Creator who creates universes very haphazardly, at random, but creates a huge number of them. Then most of these universes, of course, will be no good, at least from our point of view, but there'll be nobody there to complain about it. Then if you ask in this picture of the world, where do we expect to find ourselves, the answer is in a biofriendly universe, which allows us to exist. So this is the so-called anthropic principle, right, which says that we can only exist in those universes or in those parts of the universe which allow for the existence of life. Mm-hmm. And of course, this is trivially true. There is no dispute about that. So you need a theory that will describe this ensemble of universes. Once you have that, you can say, okay, now we have this mathematical description of this ensemble of universes, and we live somewhere. Most of them are uninhabited, some of them are inhabited, some of them have intelligent creatures, and we can ask where in this ensemble we are most likely to find ourselves. So we can try to make statistical predictions. And in fact, one of such predictions has already been confirmed. This is the prediction of the non-zero cosmological constant. So that may be our first evidence for the multiverse.
Is there a third possibility that those constants of physics which look random really have some fundamental force to them, that they can only be what they are because of something more fundamental?
Yes, sure, and this is what most physicists were hoping for, that indeed there is one theory which is the true theory of the universe, and we were hoping that someday we will, from that theory, will derive the values of all these constants of nature.
It's interesting you're using the past tense in that.
Yeah, many physicists are now doubting it. There is no question that despite tremendous effort to explain the constants of nature from fundamental theory, there is very little to show for that effort.
So does that mean you're left with literally one of two options, either a multiverse generated, however, in whatever random manner, or some sort of intelligent process that created the one universe that works?
Well, I go for multiverse. And when you look at the pattern of small scales...
Explaining the constants of nature, the fine-tuning, from fundamental theory is not working. There seems no necessity. So Alex is clear. He goes for multiple universes. Russell Stannard, a British physicist, is equally clear. He goes for God. We meet in London. Russell, you're both a scientist and a believer. And so when you look upon the fine-tuning of this universe, how do you see it?
I think the first reaction I have is that I can look upon the universe as home, a natural home for humans and also for other life forms, intelligent life forms on other planets, all right? But then you go a bit deeper, you then say, okay, well, can I use this fine-tuning as an argument for the existence of God? An argument from design. Now, as soon as you use the phrase argument from design, a cold chill goes through you because this is a path we've been down before. In the past, people would look at the human body and say, how beautifully it's designed to fulfill its function. If you found a watch on a beach is the usual illustration, and it's obviously been designed, yes? So if you look at this, it's like a watch, and therefore it must be designed. Therefore, you must believe in God. Now, we know that argument was undermined by Darwin's theory of evolution, which provides an alternative explanation of how we humans came into existence. Now, I get a bit worried, to put it mildly, that now that we've been presented with the anthropic principle, here seems to be a second argument from design, this time from physics rather than biology. It's more sophisticated, but essentially it seems to be lending itself towards a knockdown proof of God's existence. And, okay, that is countered by the multiverse idea that, okay, perhaps our universe is not alone, there are other universes, they're all run on different lines, and that if you have enough of them, an infinite number of them, then purely by chance, one or more is going to be a freak universe, which happens to be suitable for life development. And we, being a form of life, of course, have to find ourselves in one of the freak universes. Okay, one can knock the multiverse idea by saying, well, prove it, and okay, you're not going to be able to prove it because by definition these are universes other than our own, and so we're not going to be able to make contact with them. So what does that leave us with? Does that leave us with the religious view that there is one universe and it's fine-tuned, or the atheistic view that there are many universes? I don't see it like that at all, and the reason is that I don't see why God shouldn't have made many universes.
So what are the implications? Does this mean that this universe or one of the multi-universes must bring forth life and then ultimately consciousness?
Well, believing in God and thinking that one of his aims was to bring us into being. I say one because I think that we have to recognize that for the bulk of the existence of the universe, there wasn't life here, and there'll come a stage when there will no longer be life, but there's no reason why God shouldn't continue to enjoy this universe. And if we can enjoy this universe without life in it, then I'm sure he can enjoy other universes. So I would say that God probably had a multiplicity of reasons for producing things, okay? I don't mind whether there was a multiverse or just one single fine-tuned universe. It's all due to God. I think
Some scientists are embarrassed to talk seriously about God. Not Russell. He tells a good story, how God created the universe, or many universes. Either way, he doesn't much mind. Whatever we've got from God. Roger Penrose, a distinguished mathematician and cosmologist, delights in new ways to explain the unexplainable. His targets? The initial conditions of the universe and the cause of consciousness. Both are formidable. Where does fine-tuning fit? We meet at Oxford. Roger, is the universe fine-tuned, particularly the initial condition?
Well, the universe is certainly fine-tuned in the sense that the initial state of the universe was extraordinarily special. Now, usually when people talk about this fine-tuning, they're talking about something quite different. They refer to the constants of nature, which could conceivably have quite different values. It's certainly the case that if these numbers had different values, and sometimes not very different values, then life as we know it couldn't have happened. But that doesn't mean that some kind of life, or some kind of consciousness, which is really what you need, because a conscious being, in these anthropic arguments, you say, well, how could consciousness have arisen? That's the key point. And since we have such little understanding of what consciousness is and what's the necessary prerequisite for consciousness, okay, the argument is a genuine one, it's a genuine question, but it's so far from being able to be answered that I really see it's almost unusable in most circumstances.
So the fine-tuning is fine-tuning for our life, but that doesn't mean that other kinds of tunes can play other kinds of lives.
Exactly. Now there's fine-tuning in the origin of the universe, which has to do with the second law of thermodynamics. It has to have been extraordinarily precise, and in fact it has to have been at least as precise as 1 part in 10 to the power 123. Now that's
It's an
a ridiculous
extraordinary number.
It's a ridiculous number, yes. That's right. People worry about the constants of nature. You see, you want to fix those constants, and that's nothing by comparison with this number. The precision that we see in the initial state of the universe completely dwarfs any of these other considerations.
Now, what does that really mean, though, that precision in the initial condition based on the second law?
Well, what it means is that the anthropic argument is useless for explaining it, why the universe was so precise. It has to be a completely different kind of explanation.
But going back to the initial condition and the incredible specificity that the universe had to have, that level of precision is so impossible to conceive of as from some random point of view. I mean, in infinity you can do anything, but obviously, but that's a...
It's no explanation. I mean, that's right. I mean, you can't say, well, there are lots of universes, and out of that particular one, which we happen to be in, that number was that thing. Well, no, it doesn't explain it. You don't get anywhere close to that number.
Right.
Okay, it might have something to say about these few constants of nature, which we have trouble in explaining why they fit together in certain ways. But that's chicken feed by comparison with the special nature of the Big Bang. And the anthropic argument gets you nowhere.
This is an even deeper mystery than the anthropic people normally put out for us.
Yes, it is, yes. No, it needs a scientific explanation. It needs a good physical theory to say why the Big Bang had that nature that it did. And we have no theory which really explains that.
Regarding the fine-tuning problem, I see 4 kinds of solutions. 1. Multiple universes, which most scientists now espouse. Chance. 2. Some still search for the one law, a mathematical structure that can be only one way. Necessity. 3. A few seek radical revisions of science, perhaps a deeper kind of necessity. 4. Others believe in a creator, God. The big gainer is multiple universes, perhaps infinite universes. Chance on steroids. Multiple universes is now the leading candidate because the search for necessity has not borne fruit, and many scientists are pessimistic that it ever will. To some, a good enough reason for multiple universes is that what may become the only alternative, a special purpose or meaning, is categorically unacceptable. But maybe we're still too soon in the search, and some kind of necessity will eventually emerge. I like that we've got all the categories, even if further progress may not be possible. I focus on fine-tuning to get closer to truth.
For complete interviews and for further information, please visit closertotruth.com.